Welcome to Module 6, Lesson 1, Ratios. Today we're going to talk about ratios and how to use ratio language to explain what a ratio means and to create ratios. We're going to use it to solve real-world problems. We're going to find missing values that make ratios equivalent and create equivalent ratios, and then also determine if two or more ratios are equivalent. Right? So again, we have to remember ratios can be written in fraction form, but they are not fractions. So here we go. When we're talking about a ratio, we're comparing the amount of one thing to the amount of another thing. So for example, the ratio of star-shaped beads to moon-shaped beads and a bracelet is 3 to 1. So for every 3 stars, I put on 1 moon. So I want to write the ratio of moon beads to star beads. The order matters because it tells you, so if I were to write 3 to 1, that implies that there would be 3 moons to every 1 star, but that's not true. It's 1 moon to every 3 stars. Okay, and now we're going to write the ratio of moon beads to all beads. So when it's all beads, we have to look at the total of the beads. So when I have 1 bead, and I look at the total would be 1, 2, 3, 4. So it will be 1, 2, 4. So for every 1 moon bead, there should be 4 total beads. And you have to include the moon in that total count because it's part of the total bracelet. If the bracelet has 2 moon beads, how many star beads should it have? Well, if you draw a picture here, so if I wanted another moon, draw myself a little moon there. Right? And then if I draw 1 more moon, we know that means that I have to draw 2 more stars. Right? So if I had 2 moons, that means that I would have to have 6 stars. So that would mean that I would have 6 stars. Okay, so now if the bracelet has 9 star beads, how many moon beads does it have? Well, let's think about this logically. 9 is 3 groups of 3, and I'm going to type so that way it goes a little faster and not that large of a font. There you go. So 9 is 3 groups of 3. Since I would have 3 groups of 3, 3 groups of 3 stars, I would need 3 moons. 1 for every group of 3 stars. So every time I have a group of 3 stars, I have to add a moon to it. So if I have 9 stars, that means I have 3 groups of 3, which means I would have to have those 3 moons. You could also draw yourself a picture and see that if I have the 3 groups of 3 and I already drew 2 groups, so I'm just going to draw them up here. So here's 9, 3 groups of 3. You can see I would need to add another moon, which would tell me I would have 3 moons. So we can use logic, we can use pictures, and we can also use multiplication, and we'll talk about that in a little bit. So we're going to write a rule that we can use to find the number of star beads in a bracelet when we know the number of moons. So how do we find the number of stars when we know the number of moons, and how do we find the number of moons when we know the number of stars? So I actually want you to take a look at it and make a guess and then come back and check your answer. So in this case, what we can do is to find the number of star beads, we could actually take the number of moons and multiply it by 3. Because every time I put 1 moon, I would have to put 3 stars. So 1 times 3 gives me 3. Or 2 times 3 gives me 6. So if I had 2 moons, I have to add 6 stars. Vice versa, if I have the number of stars, so to find the number of moons, I could take the number of stars and divide it by 3. So if I have 3 stars, take 3 divided by 3, that gives me 1. I have to have 1 moon. So there's a mathematical connection to it as well. Right? So write a rule that you can use to find the total number of beads in a bracelet when you know the number of moon beads. I want you to try this and then come back and check your answer. All right, again, since the total is larger, I would use multiplication. To find the number of total beads, I can multiply the number of moon beads by 4, because for every one moon bead, there are 4 total beads. So I could take, so if I have 2 moon beads, 2 times 4 is 8. Let's take a look and see if that works. I have 1, 2, 3 stars, and then I add a moon, and then 1, 2, 3 stars, and then I add a moon, and that gives me a total of 8 beads. Yes, I know my moons look like bananas, but let's just go with it here. All right, so next we're going to look at how we write these ratios. There's 3 different ways to write the ratios. Again, you have to write them in the correct order. So in this case, we're comparing comedies, which I'm going to use red for, and dramas, which I'm going to use blue for, because they're sad. Okay, so dramas, I see that there are 3 dramas in Sam's video collection, and there are 8 comedies in Sam's video collection. So one way to write this ratio would be 8, and then the word 2, so 8, 2, 3. Another way that we could write this is instead of the word 2, we could use a colon, and colon implies the word 2 when we talk about ratios. So again, this would be 8 to 3. And then now, since we're talking about a ratio and we're writing it in fraction form, this bar is no longer a fraction bar, it's a ratio bar, so it now refers to the word 2 instead of out of or anything in terms of fractions. So this would be 8 to 3. So here are your 3 different ways of writing your ratios. The next one, it wants the total. So it wants the ratio of the dramas to the total. So I would actually have to figure out how many videos Sam has in his collection. 8 plus 3 is 11, plus 2 is 13, plus 1 is 14. So his total is 14. So I have to have that in each of my ratios. This is what we call a part to whole ratio. Up here, when we were comparing comedy to drama, that was a part to part. Now we're comparing part of his collection to his whole collection. So in this case, for every, and we're going dramas to total, so for every 3 dramas, he'll have a total of 14 movies. For every 3 dramas, he'll have a total of 14 movies. For every 3 dramas, he'll have a total of 14 movies. Okay, so we're going to describe the relationship between the drama videos and the science fiction videos. So now we're looking at different information. We got science fiction down here. Now we're going to use specific words for this. So first, there's 2 ways that we can say it. The first way that we can say it is for every 3 drama videos, there is 1 science fiction video. So for every, there are. That is a very common way that you'll hear ratios being referred to. So for every 3 dramas that he pulls out of his collection, he'll pull out 1 science fiction video. So if he pulls out 6 dramas, he should pull out 2 science fiction. Another way we can look at it is the actual mathematical comparison. So the number of dramas is 3 times the number of science fiction movies. Because if I take 3 and multiply it by the number of science fiction movies, which is 1, and that was supposed to be in green, it should give me my total of dramas. Okay, so there are ways that we can make equations with our ratios to solve problems. And we'll dive deeper into that later on in the unit. So let's take a look at this. The ratio of floor seats to balcony seats in a theater is 20 to 1. Does the theater have more floor seats or more balcony seats, and how would we know? Well, what this tells us is that every time I count 20 floor seats, I'm only going to count 1 balcony seat. So no matter what happens, I'm always going to have more floor seats. Okay, so the theater will always have more floor seats because for every 20 floor seats, there is only 1 balcony seat. So even if there's 20 balcony seats, that means that there's going to be 400 floor seats. So there's always going to be a lot more floor seats because you see in the ratio originally that there are more floor seats than balcony seats. So no matter what I do to my ratio, my number of floor seats should always be larger than my number of balcony seats. And that's true for anything. So if I look up here, since my number of comedies is larger than my number of dramas, no matter what I do, if I double my amount of comedies and double my amount of dramas, my comedies should still be larger. So I want you to take a minute and I want you to try these problems on your own, and when you come back, we'll check your answers. All right, so when it's asking you to write them in 3 different ways, they're asking you for the 3 different forms. They're not asking you for equivalency, they're asking you for the colon, the word, and the fraction form. So here are your answers for those. Remember, when it's the total, you have to add up your total numbers. So you have to add up your 3, 3, 1, and 1, which gave you a total of 8 cups. So when you added all of this together, you had 8 cups of mix. All right, so moving on, now we're actually going to go into the equivalent ratios. So let's read the problem. We make 5 cups of punch by mixing 3 cups of cranberry juice with 2 cups of apple juice. How much cranberry juice and how much apple juice do you need to make 4 times the original recipe? So I have to highlight my question. So I want to know how much cranberry juice and how much apple juice. In this case, my important numbers are that I'm using 3 cups of cranberry juice and 2 cups, so 3 cranberry, 2 apple. And I want 4 times the original recipe. So here's 2 ways that we can do this. We can use a table, and so step 1, we create the table. And after we create the table, we fill out our information accordingly. Right, so make a table comparing the information. So make a table to compare. And start with your original. So in the original, I know that with my cranberry juice, I use 3 cups, and if I use 3 cups, I have to use 2 cups of apple juice. In this case, my total number of cups doesn't necessarily matter. I'm not using it right now. Well, if I double the recipe, so if I go from here to here, I'm going to multiply by 2. So if I double the amount of cranberry juice, I need to also double the amount of apple juice in order to stick with the recipe and make it taste the same. So if I use 6 cups of cranberry juice, I'm going to use 4 cups of apple juice. It's just like what we did with fractions. What you do to one, you have to do to the other. So if I triple the amount of my original, and I use 9 cups of cranberry juice, then I have to triple my amount of apple juice, which would be 6 cups of apple juice. Now I want 4 times. So if I quadruple my amount of cranberry juice, that's 12 cups of cranberry juice. So then I have to quadruple my amount of apple juice, which 2 times 4 tells me I would need 8 cups of apple juice. Okay, so I know the answer is, if I want to make 4 times the original recipe, I would need to use 12 cups of cranberry juice and 8 cups of apple juice. Okay, and then here, step 2, write the original ratio and the ratio that shows the amount of cranberry juice and apple juice needed to make the original recipe. So here I just double check. So I say, okay, well the original ratio was 3 to 2. Is that equivalent to 12 to 8? Well, to go from here to here, I times 4 and times 4. So I know that it is equivalent. I can always double check. So my answer, I can't just leave a number. I would need to use 12 cups of cranberry juice and 8 cups of apple juice to make 4 times the recipe. And I knew to multiply because times tells me to multiply. Okay, so there's one way that I can do it. I can use a table, and another way that I can do it is I can just straight up multiply. So I can take my original ratio, and I'm going to write it in fraction form. My original ratio was 3 to 2. For every 3 cups of cranberry, I used 2 cups of apple juice. Okay, and then what I would do is I would say, well, I want 4 times the amount. So I would multiply the numerator and the denominator by the same number, and in this case, that same number would be 4 because I want 4 times the amount. So I would take 3 to 2, and I would multiply 3 by 4, and I would multiply 2 by 4, and I would get 12 to 8. This looks exactly like what we got before, which is a good sign, and it tells me the exact same thing, that to make 4 times the recipe, I would need to use 12 cups of cranberry juice and 6 or 8 cups of apple juice. Okay, so again, you can use a table or you can just multiply. Here I want you to write 3 ratios that are equivalent to the given ratio. Now, you can have all kinds of different answers. So if your answer isn't on the video, make sure to double check with me in class the next day to check to see if you were correct. I'm only going to put up a few of them because otherwise we're going to be sitting here for days with all the correct answers. So go ahead and pause and we'll come back and check your answers. All right, so for these, from 8 to 10, you could have had 16 to 20. You could have had 24 to 30. You could have had 32 to 40. You could have had, so 8 times 4, 8 times 5 is 40 to 50. 8 times 6 is 48 to 60. 8 times 7 is 56 to 70. 8 times 8 is 64 to 80. 8 times 9 is 72 to 90. 8 times 10 is 80 to 100. Now, you could have also divided here, though. You could have taken 8 and 10 and divided them by 2 and gotten 4 to 5. So there are tons of options here. All right, 5 to 2, you could have gotten 10 to 4, 15 to 6, 20 to 8, 25 to 10, 30 to 12, 35 to 14, 40 to 16, 45 to 18, 50 to 20, 55 to 22, 60 to 24, 65 to 26, 70 to 28, 75 to 30, and I'm running out of space, so this is the last one that I'm going to do. I could have gotten 80 to 32. Again, if your answer isn't on here, just double check with me to make sure that it is correct. But these are all options that you would have had as long as you do the same thing to one that you do to the other. So again, times 2, and I got 10 to 4. All right, so what you're going to do is you're going to answer these questions in your guided practice, and you're going to put them into the Google form. And as always, if you have any questions, please be sure to write them down or email me so we can go over them in class.